So far we have solved a system of equation using matrix for the cases when there is single solution. But in practice there are more types, and you know that from college algebra, when system of equation doesn't have solution or has infinite amount of solution. If a consistent system has an infinite number of solution, we call it dependent system. So if a system has infinite amount of solutions, then the system is dependent. So when you graph such a system of equation, you get one graph, same line for every single system, equation in the system. If a system has no solution, it is said to be inconsistent. So we are going to deal with inconsistent and dependent systems of equations, which means no solution and infinitely many solutions. And we are going to deal with those via matrices. And then in the next video, I will explain how to identify such problems, such systems via rank of matrix. So let's start to solve system that are inconsistent first. We have 4x1 plus, minus 3x2 plus 2x3 minus x4 is equal 8. Next, we have 3x1 minus 2x2 plus x3 minus 3x4 equals 7. And lastly, we have 5x1 minus 3x2 plus x3 minus 8x4 equal 1. Okay. So, the elementary transformations of the matrix themselves are going to be exactly the same. So we are going to use Gauss-Jordan method to do transformation. The difference you will see at the end of the solution. So what is immediately catches your eye in this system? That the number of equations is less than number of variables. So in my previous video, I mentioned that when number of equation is less than the number of variables, then we can immediately say that system can be inconsistent. But here I will add also not only inconsistent, it can be also that has infinitely many solutions. So which one it is, we are going to find out. So the beginning of solution is absolutely ordinary. We are going to write down the extended matrix of the system, and using basic transformations we learned, bring it to echelon form. So we have, let's write down in the form of matrix 4, -3, 2, -1, and 8. Next, 3, -2, 1, -3, and 7. I'm writing down their coefficients, obviously. And as you can see, every single equation has x1, x2, x3, x4. If, let's say, in one of them, let's say x2 would be missing, I wouldn't move ahead x3, like, let's say, second one, right? Let's say if we wouldn't have this, it would be gone. Let's say we wouldn't have this, right? We'll have 3x1 plus x3 minus 3x2, x4, then what I would do, instead of this negative 2, I would put 0. And I won't shift this 2 into this position. No, I have to place missing 0. It's should remind you long division of polynomials. Whoever is interested, you can look into playlist, find playlist polynomials and find their long division. That's exactly same way. If in order something is missing, one of these x's, then we place 0. Okay, next we have 5, negative 3, oops, this one instead of 0 we're supposed to have negative 2. Okay, 5, negative 3, 1, negative 8, and 1. Okay, this is our extended matrix. So remember we said that I mentioned several times that we need the best way to start to have in the first position, first column, first row, have here 1, with the purpose not deal with fractions down the road. Therefore, how can I get 1? I can do the following: R1 minus R3, right? And write down in R1. Okay? And we are going to get, if we subtract, first row, let me write down here, first row, second row, and third row, or line, whatever you prefer. So 4 minus 5, it's going to be negative 1. Negative 3 minus negative 3, it's going to be 0. And then 2 minus 1, we are getting 1. Negative 1 minus negative 8, we are getting 7. And 8 minus 1, we are getting 7. Second row we leave alone. And the third row we leave alone. We don't mix anything. Okay. So what we are going to do next? Next we are going to these numbers under leading coefficient negative 1, these numbers convert to 0, these 3 and 5. So under every leading coefficient, we are going to get zeros. So let's say this 3 and this 5 is going to be 0. And for that, we are going to do the following. Since our leading coefficient is negative 1 in the first line, that's mean to get 0 in the second line, first column, and third line, first column, we need to manipulate with this first line, okay? Wherever we have for a leading coefficient, and that row we are going to manipulate with to get 0 in the same column. All right, so this is what I'm going to do here. For that purpose, to get 3, 0, I'm going to multiply R1 3 times, because I have here 3. I need here also 3, right? So when I subtract, I get 0. R1, 3 times R1 plus second row R2. And we write down in the second row R2. Okay, and at the same time we can do the same changes with the third row. which means I'm going to do this time, since I have 5, then first row I am multiplying by 5 times plus R3 and writing down in R5. Let me clean this, is making mess. Let me make it look nice and readable. Okay, like this. And as a result, we are going to get, so 3 times, we are getting multiplied by 3. It's going to be in the first line, it's going to be negative 3, 0, 3, 21. Now, once we subtract, so the first line is going to stay the same. This is, I multiply so we can do operation. So negative 1, 0, 1, 7, 7. Oh, this is also, we didn't multiply. Okay, now let's see. Second line, 3 minus 3 plus negative 3. We are getting 0. I was staring and I'm thinking, I'm not getting any 0. Okay, 2 plus 0, I am going to get negative 2. Negative 2 plus 0, negative 2. Third one, 1 plus 3, I'm getting 4. And the fourth one, negative 3 plus 21, I'm getting positive 18, right? And 7 plus, this 7 plus 21, I'm getting 28. Same thing I am doing with, let me clean this. Okay, now same thing we are doing with, oops, here is supposed to be, no, all is good. I multiply by first row by 5. And we are getting negative 5, 0, 5, 35, 35, and adding to row 3. Okay, let's go. 5 minus 5 is 0. So see, we got zeros under this leading coefficient negative 1 in the first row. Next, negative 3 plus 0, we are getting negative 3. 1 plus 5, we are getting 6, and negative 8 plus 35, we are getting 27. And 1 plus 35, we are getting 36. Okay. So we made 0, every single number in the column of leading coefficient negative 1. Now we are taking, what do we have? After we perform this transformation, it's always beneficial to check, first of all, to check if it's possible to simplify any resulting lines. So I'm looking here, the second row, look what we have, 2, 4, 18, 28. I can simplify and divide the second row by 2. And this way, if I divide by 2, instead of negative 2, I will get this negative 1 that is required. See, getting echelon form, look here. And third one will be this 6, right? So now if we divide by divide by 2, we get negative 1. Okay, let's do it. R2, we divide by 2 and write down in R2. Okay, and we are getting, what we are going to get, the first one is going to stay the way it is, first line. It's going to be negative 1, 0, 1, 7, 7. Second one, we are going to divide by 2, and it's going to be 0, negative 2 by 2, negative 1, right? And then 4 divided by 2 is 2, and what else? 18 by 2 is 9, and extended 1 is 14. Yes? And the third one, it's gonna be, let me see, the third one, we have negative 3, 6, 27, 36. We can divide by 3 and write down in R3. So it will be 0, it's gonna be by negative 3, let's see, it's gonna be 1, 6 by negative 3, it's getting negative 2, and 27 by negative 3, we are getting negative 9, 36 by negative 3, we are getting negative 12. All right, and lastly, because we have here, look, this is our echelon format. So we need to get this one 0, it's a 0, right? Under this, the second leading coefficient negative 1 in the second line. So what can we do? All we can do, I don't need to, I have to do manipulation with R2, right? With this second line manipulation. Why? Because our leading coefficient is in second line. Therefore, I'm going to do manipulation with second line to get 0 in this third line. So I'm going to, what do we do? Subtract or add, rather saying it's negative, add second and third line. Okay, let's do that. R2 plus R3, and we write down in R3. And as a result, let me write down first one, negative 1, 0, 1, 7, 7. And then we have 0, negative 1, 2, and 9. Here is 14. We don't change second. Now third one, we are going to add to second one, right? So 0 is plus 0 is 0. 1 plus negative 1 is 0. Negative 2 plus 2 is 0. Negative 9 plus 9 is 0. And negative 12 plus 14 is 2. And we got the following format. So let me write down. So it's gonna be, write down this way. Negative 1 is negative x1. So x2 is practically, it's gonna be 0, is missing. And then we have plus x3. And we have plus 7x4, and that is equal 7. Next, second one is negative x2 plus 2x3 plus 9x4 is equal 14. And the third one, 0 equal 2. Okay, so as a result, we are getting here the fact that 0 is equal 2, which is not gonna happen, right? So therefore, we are saying the system has no solution, which is system is inconsistent. Okay. Now let's solve a system of linear equation that has infinitely many solutions. So we have 2x1 plus 3x2 minus x2, x3 plus x4 equal 1. 8 x2 x1 plus 12 x2 minus 9 x3 plus 8 x4, and it's equal 3. Next, 4x1 plus 6x2 plus 3x3 minus 2x4, and it's equal 3. And lastly, 2x1 plus 3x2 plus 9x3 minus 7x4, and it's equal 3. Okay, we have here the system of 4 equations and 4 variables, 4 unknown. So the system can have either one solution or no solution, or have infinite many solutions. So, and we are going to use Gauss method that will lead us to the answer one way or another. So, the beginning is again standard. Let's write down the extended matrix of the system, and using elementary transformation, bring it to echelon form. So we are going to have matrix 2, 3, negative 1, positive 1, and here is 1, extended matrix. We have 8, 12, negative 9, 8, and 3. We have 4, 6, 3, negative 2 and 3. And we have 2, 3, 9, negative 7, and 3. So we wrote down in the form of matrix. So usually we would jump to get this first number, bring to the level of 1, right? But when I'm looking at this first column here, all these numbers are divisible by 2, right? Therefore, there is no threat that doing all kinds of manipulation like addition, subtraction, or multiplication, I will end up actually only in the case of addition, subtraction, I will end up with any fractional portion or any complicated case. So because all of them are divisible by 2, then I can leave it as a 2, the leading coefficient. Okay, so let's start working. So 2 is going, we accept as our leading coefficient. So our job is fill out with zeros these 3 elements of the same column where the leading coefficient is. Okay, so what we are going to do, first of all, to get a 0 where 8 is, this 8 is, I'm going to multiply by 4. Let me see. I'm going to multiply by 4 first line, right? And do R2 second line minus first line multiply by 4. Okay. At the same time, I'm going to fill out with 0 second one and third one also. I can do it at the same time. Let's do it. So for the third line, I have to do R3 minus twice R1, right? So I can get 4 and then do 4 minus 4 to get 0. And for the fourth one, I'm not touching anything because I have two leading coefficient and 2 is in the fourth line. So all I will do is R4 minus R1. So I'm going to do everything at once and get rid of it. So get it final simplification. So let's see. First I'm working on R2 minus 4 times R1. Let's write down 4 times. It's going to be 8, 12, negative 4, 4, and 4. So we are going to do 8 minus 8, 12 minus 12, 9 minus negative 4, and so on. Let's work on it. First line obviously gonna stay the same way. We don't touch it. Okay. Now for the second line, 8 minus 8 is 0. 12 minus 12 is 0. So negative 9 minus negative 4, it's going to be negative 9 plus 4, it's going to be negative 5. And 8 minus 4, it's going to be 4. And 3 minus 4, it's going to be negative 1. Okay, so let's clean this and prepare for the next one. R3 minus 2 R1, so we need to multiply by 2 this time. It's going to be 4 by 2 is 6, negative 2, 2, and 2. Okay, now we're subtracting the first line from the third one. Okay, what we get? 4 minus 4 is 0. 6 minus 6 is 0. 3 minus negative 2, it's going to be 3 plus 2 is 5. Negative 2 minus 2, it's going to be negative 4. And 3 minus 2, it's going to be 1. And the last one, R4 minus R1, we are getting 0. Oops. 0, 0, 9 minus negative 1, it's going to be positive 10, and then negative 8 and 2. Okay, we simplified so the 3 lines in, well, it's not simplified, we got zeros under leading coefficient 2. Okay, so what is interesting, look at the second line, third line, and fourth one. They are linearly proportional, right? So if I multiply second line by negative 1, I get identical as a third one. And the fourth one, if I divide by 2, I'll get same as a second and third one. So what does that mean? That means I'm throwing out a window these 2 of them. I don't need 3 identical ones. So I'm going to throw third one, fourth one, and keep the second one only. And as a result, we are going to get 2, 3, negative 1, 1, 1, and 0, 0, 5, negative 4, and 1. So I just got rid of negative 1. Multiplied by negative 1, got rid of it. Okay, so this is all. Now, now what we are going to do. We are going to find out the solution for this one. So we brought to echelon form. And what is interesting, our leading coefficients are going to be x1, coefficient of x1, because we have what? x1, x2, x3, x4, right? Look at the original equation. This is how we got, right? Coefficient of x1, x2, x3, x4. Okay, so let me clean this also, not to leave mess. Okay, x2 doesn't have leading coefficient because it's 2, so we skip it. And the second leading coefficient is x3, right? A coefficient of x3, and that's it. So our x1 and x3, our variables of leading coefficients, right? And x2 and x4, those are free variables. Those are free variables. How it's going to affect, why do we assign this definition, and how I'm going to work further with this. So x2 and x4 are free variables. Okay, and x1 and x2, variables of leading coefficient, or leading variables, leading coefficient. Okay, so we are going to now rewrite this equation, and we are getting 2x1 plus 3x2 minus x3 plus x4 is equal 1. And the second one is going to be 5x3 minus 4x4, and it's equal 1. So this is what we are going to do now. We are going to, since x2 and x4 are free variables, so our fundamental variables, x1 and x3, those are variables of our leading coefficient that do exist in this equation, system of equation. We are going to express our variables of leading coefficients through free variables. We call it free because they can accept, we can have any value, but x1 and x3, they are leading ones. We cannot assign them any values, arbitrary numbers. Therefore, we are going to express x1 and x3 through x2 and x4. So what's going to happen? I'm starting with a second equation, 5x3 minus 4x4 equal 1, and get from here x3. So x3 from here is going to be 4/5 of x4 and plus 1/5. Okay, so this is the solution for x3. Now I'm going to find x1 expressed through x2 and x4. How I'm going to do? Okay, I'm going to write down in the following way. Find out from the first one. I'm going to write down how much is 2x1 is equal. So 2x1 is equal 1 minus 3x2 plus 4/5 x4 plus 1/5 and minus x4. What did I do? This 4/5 x4 plus 1/5, I plug instead of x3. Okay? Because we have their x3, I can't keep fundamental variable or variable of leading coefficient involved with another fundamental variable. Why I can't allow to be involved these two together? Because we cannot assign any arbitrary variable, arbitrary value. Okay, this is why we need to get rid of x3 in the x1 and replace with x2 and x4. Okay, so now we have here expressed with x2 and x4. Let me clean this. And from here, I'm going to get x1 will be equal negative 3 over 2 x2. I'm going to combine this 1 and 1/5, okay? And these two also, like terms. So negative 3 over 2, 3 over 2 x2. Okay, let me go step by step. So 2x 1 is equal negative 3x2 minus 1/5 x4. I combine them. Negative 1 and 4/5 is going to be negative 1/5 x4 and plus 6/5. Combine these available terms. And only then from here x1 is equal negative 3 over 2 x2 minus 1 over 10 x4 and plus 3 over 5. We divided by 2 everything, right? So the result was what we needed. All our fundamental variables x2, x1 and x3, this is x3, and this is x1. We expressed through only three variables x2 and x4. So this is going to be actually our solution. So let me see. The answer is going to be, we usually put x1, x2, x3, x4, right? Because we have 4 variables. And this is how we're going to do. Our x1 is equal negative 3 over 2 x2 minus 1 over 10 x4 and plus 3/5. This is our x1. x2, because it's 3 variables, stays just like that because we can assign any value. x3, when I'm writing expression for x3, 4/5 of x4 plus 1/5. And x4 is also a free variable. We just write down as x4. Okay, so this is our solution. Now we are going to show how many solutions has this solution. How many answers we can get through this solution. Okay. What I'm going to do, I'm going to take some arbitrary value for free variables, which is x2 and x4, and show that this answer satisfies to infinitely many solutions. So the value I'm going to take first, it's going to be x2 and x4 equals 0. I'm taking easy case. If you are interested to take more complicated cases, be my guest. So I'm taking first x2 is equal 0, x4 is equal 0. Then I will take 1 and 1. Okay, let's see what we will get. Once we plug 0, for this case, x1, it's going to be only 3 over 5, right? Because this is going to be 0, this is 0, and will be only 3/5. So 3/5. Second one, x2, we assign 0, arbitrary 0, it's going to be 0. Third, x3 is, if we calculate, it's going to be 1/5, because this is going to be 0, will be left 1/5. And x4 obviously also going to be 0. So this is the answer for x2 and 4 equal 0. This is in this particular solution. Now let's take another case. X2 is equal 1 and x4 is equal 1. So what's going to happen in this case? X3 is going to be negative 3 over 2 minus 1/10 and plus 3/5, right? X2 is going to be 1. X3 is going to be 4/5 plus 1/5. And x4 is going to be also 1. So if we do this math, let's see. Well, I need to bring to common denominator. Let me do it separate here, do it as a drafting. Negative 3 over 2 minus 1/10 plus 3/5. Denominator is 10, which means here is multiplying by 5, by 2, and we are getting, so negative 15 minus 1 plus 6. So negative 16 plus 6 is going to be negative 10 over 10, going to be negative 1. Okay. So once we solve it, we are getting negative 1, 1. 4/5 plus 1/5 is also 1 and 1. So this is solution for answer for the x2 is equal 1 and x4 is equal 1. So this is showing that equation has infinitely many solutions since we can assign any value to these three variables. Now, how we can check the answer if we did right or wrong? All you're going to do, take these answers, either this fraction. I'm not going to do it. I don't want to deal with fractions right now. Although I love fractions, those are they are precise numbers comparing to decimals. But right now, I'm just for the sake of time, not to make it a long video, I'm going to take this easy case. And if you plug to original problem, this one, trust me, you will get the answer because I have checked already. Okay, let's do this one. Negative 1 is x1, the rest is 1. Let's plug it. This is negative 1, 1, 1, 1. So this is going to be negative 2 plus 1 plus 3 minus 1 plus 1 equal 1. So this is going to be 1. 1 minus 1 is 0. We get 1 is equal 1. So it satisfies this one. The same way we can do second one, third one, fourth one. It's going to satisfy. Trust me. So therefore, this is a true solution, true answer. One of these answers of infinitely many solutions. The other way also to check, plug this data, this answer. Oops. Plug this answer. It's going to be a little bit time consuming, but you will get the answer. This will be more accurate if you plug this expression. Plug it back and check why more accurate. Maybe because two answers, if it's correct, and then third one I solve it, plug it back, it won't satisfy. But if you get the original, this answer expression, and plug it back, you don't have to take arbitrary numbers anymore. If you simplify, get the result. If anybody would like me to do it, just put it in the comment and I will do it. Or you can crunch the numbers yourself. And if you plug x1, this expression, and plug x2 as an x2, plug x3 as an x3, and this is x4, and trust me, you will get the answer in this case, at least. Okay. All right, so I'm done, and I'll see you in next video.